here, or are they just not here? We don't know.
Keep
Okay,
it here.
so
Maya's not here.
we're really
Andrew
going
Maya.
to, this is kind of an extension of the last lesson, where, what did we have to do? We found the general solution or a particular solution, where we moved the dx to the other side, we integrated both sides, right? We got the plus c, now we plug back in, and then we solve for y. So this one is it's basically the same, but it's where we have x and y involved on both sides of the equation. Okay, so what we do is oops, didn't mean to cross that out, highlight. We are going to separate the variables. So in other words, we're going to move the dx to this side. So that means we only want x on the right side. So let me just show you here. Here's x over y dx. So I'm okay that there's an x on the right side, but I want to get rid of that y. How would we get rid of the y? Multiply both sides by y. So we're going to have y dy equals x dx. So now we can integrate. Okay, so we're going to take the integral of both sides. Now, previously, we just had an integral and then dy, so we said that was equal to y. But now it's a y here. So what would be the antiderivative of y? Just think power rule. Think it's y to the first, so it's going to become y to the second over 2. Technically, there's a plus c here, but because there's a plus c on both sides, I just could have put it on the right side.
What's x to the second over 2.
X to the second over 2 plus c. Okay, so again, it's kind of like step 1, we separate variables.
Wait, why is it plus c on that side?
Okay, technically it would be a plus c on both sides. It would be like this. It would be y squared over 2 plus c1, and then x squared over 2 plus c2. But I just want to have the constant on one side. Well, what happens if you have a constant minus a different constant?
They go out.
It's still just a constant. They're not canceled because we don't necessarily
it's
know
not
if they're
the
the
same
same.
It's just
So
okay.
technically there is a plus c on both sides, but we don't know what that constant is, so it's easier
Just
for us to
combining them
just
and make it another
combining it and just putting it on the right side of the equation. Yeah.
So what happens to the dy and dx?
Okay, so remember the integral sign and the dy.
What no y
That
come out?
means that we take the antiderivative of y. These combined go away when you do the power rule. These two pieces combined go away when you do the power rule.
Wouldn't the variable come out of it? Like from it? Is that not what we've been doing?
Oh, if you just had an integral sign and then a dy, like we did yesterday,
Why?
then it would just be y. Because technically, when we had this before and it looked like this, there was technically a 1 there. So what do I get? I get a y. But now what happens if I have a y? It's y squared over 2. What if it was the integral of y squared dy? Whoops. It'd be y to the third over 3. So you basically integrate whatever's inside, and really there was a 1 here when we were doing the problems yesterday. So if you think about doing the power rule there, that's what you would have. Okay, so let's continue. Now, so step 1 would separate the variable. 2, we're going to integrate both sides. Step 3 is going to be solve for c. So that's where our condition comes in. So y equals 1 when x equals 2. So I have 1 squared over 2 equals 2 squared over 2 plus c.
This is the same thing we did yesterday, right?
Yeah, so far it's, the only thing that's different is that we have x and y to kind of contend with, that we have to move y over to the other side.
Y is 1 and X is, oh, it says.
Oh, it's right there. Okay, so we plug in, so we can solve for, so we have 1/2 equals 2 plus c. So if I subtract 2, what's a half minus 2? Good. Okay, now this is where, so step 4, we're going to plug c.
Back into the original.
Yeah, we're gonna plug C back into the equation and solve for y. Okay, now, yesterday it was really easy because it was already y equals something, right? So we just put the c at the very end. We're gonna go, see where I put step 3? Y squared over 2 equals x squared over 2 plus c? That's where we're gonna plug in. So our plus c ended up being a minus 3/2. Now I want to isolate y, and this is where it gets a little tricky because you can only have one particular solution.
Can we multiply everything by 2?
Okay, so let's multiply everything by 2. That'll make it easier. So if I multiply everything by 2, we get y squared equals x squared minus 3.
And then a root both sides.
Okay, and then we're going to take the square root of both sides. Now, when we get the square root of both sides, technically we do get plus or minus, but we only want 1. We need the solution that makes the initial condition true. Now, our initial condition was the,
Y equals 1.
right, y equals 1 when x equals 2. So it's kind of like this. If I plug in 1, 1 equals plus or minus square root of 2 squared minus 3. Do I want, I want the positive one, right? So my solution is y equals positive square root of x minus 3.
You go.
If I had, how far? Here? Okay. If you follow those 4 steps, it's pretty, I don't want to say it's easy, but it's like the same thing every time. It's like separate the variables, integrate both sides, solve for c, and then plug back in and solve. And then the very last piece was just, you want to just double check, go back to the point that you were given in the very beginning, plug it in and just make sure that it's true. Sometimes you won't have a plus or a minus, but if you do have plus or minus, you want to just make sure that you're using the right one.
What are those, on the right under where you wrote the description for step 4, there's like a weird, it's like a,
Those are multiplied by 2.
Oh, that's multiplied by 2. My 2 got a little weird looking.
Consulting here on the screen.
wait, up a tiny bit.
Wait,
It's
what?
like up one little thing. There you go.
This is a 2. That didn't look like a 2.
Well, I wasn't sure.
Okay. Now it looks like a 2.
Could have been a Z before.
Well, that's because
Backwards S maybe.
that's true. Owen was really excited this year because he came home and he goes, I know how to write a 2 in cursive. That was with the loop. Which looks a lot better than his normal 2s. He does not have very good writing.
He has like guy writing?
His, like, yeah, pretty bad writing.
I just have weird writing like that.
No, if you saw his rating, I'll bring in something that he wrote. It's
We gotta
pretty.
change it now, we gotta make it cheaper right now. Really, it's,
He's working on it,
Just
but
making a left.
it's work harder.
He- he has to work harder. Well, it's more than just that. It takes him a lot longer to write stuff down too. Okay, good?
No.
All right, well. Maybe if you were here on time.
Can I have 10 seconds, please?
5,
Three.
I said 10.
2, 1.
Ben can just look on the screen, guys.
Yeah, I'm
Okay,
doing a
we're good.
screencast for the people that are gone. Okay, let's try this one. Okay, first thing, before I even separate, well, actually, you can move the dx over to the other side. And I'm actually going to square both x squared and y squared for this one.
Divide by y squared.
Divide by y squared, so I'll have, so first step, if you recall in the last one, was to separate the variables. So I have x squared dx here. I'm going to write this as y to the negative 2 dy. It just makes it easier when we have to do the power rule. on the first step? Okay, what's the second step? Integrate both sides.
So,
So we're gonna put the squiggly in front. Now remember, when I apply the power rule for integration, the squiggly and the dx or the squiggly and the dy go away. So what's y to the negative 2 become?
y to the negative 1 over y.
Okay, y to the negative 1 over negative 1. It would be a plus c, but remember, we're just gonna put the plus c on the right side to make it easier. X to the third over 3, and then we'll put the plus c here.
I think I got it.
I would probably, just because it makes it easier when we substitute in, I would make this a negative 1 over y equals x to the third over 3 plus c. Okay, what's the next step?
Plug in y, right?
Okay, so plug in our initial condition, which was y equals 1 when x equals 1. So that makes it a little, so we want to solve for c. So we have a negative 1 equals 1/3 plus c. So c is negative 4/3. Right? We have a negative 1, subtract a third would be negative 1 1/3 or negative 4/3. Okay. And now the last part. We're going to plug c back in. Where do we plug c back in? Okay. We always plug it back in to where we left off here. So after we integrated, that's where you plug in, because obviously you don't have a c until that point. So we're going to plug in negative 4/3. So I have negative 1 over y equals x to the third over 3 minus 4/3. Now from here it's just algebra, but I know sometimes the algebra gets a little complicated and it's easy to get like a sign switched around. How would you solve for y? Any ideas, Carmel? Oh, what were you going to say, Carmel? You would what?
Solve for y.
Yeah, what would you do?
Can we switch it so that the y's on top? and then
Yes, we
down?
can. But if we're going to do that, we need to write this right side as just one fraction. Well, it's convenient that they have a common denominator. So it's funny how things work out like that. So if I rewrite this, I could write this as a negative y equals 3 over x cubed minus 4.
Wait, what?
Oh, yeah, those.
Okay, it's basically
Why
taking the
is it-
reciprocal of both sides.
Why is
You
it?
could do that.
What do you multiply?
Why did you do negative y?
I think they just did a rule. There was a step.
You're essentially multiplying both sides by both.
No, I didn't skip any steps.
Why isn't the y to the negative first power?
It's the reciprocal rule. Like if I have 1 over x equals 3 over
You
4,
just flipped everything.
I can make it x is equal to 4 over 3. How could I prove that? Well, you could just cross multiply and you would see, like here's 3x is equal to 4, so x is equal to 4/3. But you, right, when you cross multiply, that's what you would get. I could take the time to cross multiply everything.
Can't you just really like
That'd be
multiply
laborious.
x to both sides and then 4/3 to both sides? Like you're on the one you drew on the board. Like, or you can't just multiply both sides and
Yeah, but that's still cross multiplying. That's just
Yeah.
a form of cross multiplication.
And then you plug in the.
Oh, let's not forget the y. The negative in front of y. So I'm just going to make this a y equals negative 3 over x cubed minus 4.
Plug in the original condition.
Yeah, so we want to make sure when we, so just check initial condition just to make sure that we don't have to put any restrictions or change anything. So if I plug in 1, 1, does that work?
yeah.
Yeah. Just a quick note here, the domain, you're going to end up with vertical asymptotes. I'm not going to worry about that so much for you guys. I'll be okay if you get it to this point, we're good. It does work, right? Because you'd have negative 3 over negative 3, which gives us a positive 1.
I have a quick,
Sure.
non-relevant question, but it's quick.
How are you?
Is the final gonna be cumulative?
It's just second semester.
Okay, so we don't need to know limits.
No chapter.
No limits and stuff.
Jesus.
Well,
No chapter.
What if we check initial condition?
it means
Y
plug
equals
1 and 1 in and just make sure that this works. when I
Works in what sense? That
This
it's not
answer.
undefined?
So in the previous one, we ended up with a plus or a minus, and we
Right.
discovered that the negative, it's just a good idea at the end. We didn't end up with a plus or a minus here, but it's always a good idea to just make sure.
But it won't happen like, we're not gonna be given a domain or anything, it just can't be undefined.
Right. We might have to restrict the domain at times, but, like possibly the next one, or when we have a square root. Okay, do you wanna try the next one?
Yeah.
I mean, like on your own, or you wanna do one more together?
I wanna do it.
This one's tricky because it has an ln.
It's
Don't
a
walk
very
the
strong
screen off
option.
and relearn it.
Oops. Yep.
We're always on the screen.
See, that Andrew isn't here, we don't, we're just saying this.
Okay, are we all right if I just write it 1 over y? If you wrote y to the negative 1, that's fine. That, we just leave the 2. Now, notice you had a 2 in your coefficient of x. You could have divided by 2y, but I would leave the coefficient on the right side. It'll make it easier when we integrate. Yeah. Yeah, so let's integrate both sides. Oops. That's not a pretty color. So what is this? This is ln of absolute value of y. Don't forget absolute value. That's important.
By absolute value.
Anytime you
That's the
take-
rule.
That's-
Anytime you do the integral, it's ln. And then what happens with 2x? It becomes 2x squared over 2, so just x squared plus c. Okay, next step, we're going to take y equals 1 when x equals 2 and plug it in. So ln of absolute value of 1 equals 2 squared plus c. What's ln of 1?
0.
0. Good. So what's c equal?
-4.
Good. So now I'm going to go back to ln. I'm going to basically go back to that point. Okay, ideas. How do we solve for y? How do we get rid of ln?
Oh yeah, the.
Is that what you're gonna say, Ben?
The x squared minus 4 equals y.
E to both sides. E to the ln of absolute value. Keep absolute value for now. Equals e to the x squared minus 4. Okay. So absolute value of y equals e to the x squared minus 4. That means y could be equal to positive or negative
Okay, that's where that
e
one's
to the x squared minus 4. So when we work with logarithms, there's a reason why, when you have the absolute value of y, that means you could have a positive or a negative on the right side. So plugging back in our initial condition, so when x equals 2, y equals 1, are we going to get a positive or negative here? You understand? Let's check. So just check initial condition.
You get positive.
Yeah, what if y was negative 1? Then you would want, it wouldn't work? Yeah, it would.
One equals negative. It'd be negative 1 equals 1.
Well, no, I'm saying,
Because x is squared, so no matter what, that's gonna be positive.
so it's plus or minus, so basically that's what we're trying to see.
Oh.
E to the 2 squared minus 4, so that would give us e to the 0, which is 1. So we want the positive. What I'm saying is there are some occasions where y would be negative 1, and then you would want to make sure that you would use the negative part of the exponential function. So it's going to be, so what's our answer? It's y equals e to the x squared minus 4. That was pretty easy.
Yes.
I did, just to, not to like make